Right, this is our third real-world project, and the conform here is going to provide a bit more of a challenge. I've deliberately made sure that some things go wrong with this conform, so that we have an exercise in troubleshooting and making sure that we get a difficult scene into the right position. In a feature film, in a large-scale project, somewhere, somehow, some things will go wrong, and we just have to know how to deal with these things. We need to know how to troubleshoot these things, and that's the point of me creating this XML and making sure there are errors within. So the first thing we're going to do, we're going to make our first three bins here. We've got our rushes, our offline, and our timelines bin. And then we're going to navigate to the Scary Crows folder, which you should have downloaded from Dropbox. So here I've got three folders. I've got my trimmed footage, I've got a temp folder, which I'm going to ignore, and I've got my offline file. Now, seeing as I'm already here, I'm going to pull my offline file into my offline folder, and to do that, we right-click, add as offline reference clip, and of course we then have the little checkerboard down here showing us that it's offline. It can never actually be placed on a timeline now under any circumstances. Resolve will actively prevent that from happening. Now the next thing I'm going to do is go into my rushes folder. I'm going to get my trimmed footage, right click and choose add folder and subfolders into media pool. Now this particular folder isn't very well organized deliberately because it's meant to give us a challenge to work with. So using the create bins option here is not the way we want to go. What we want to do is add the folder and subfolders into media pool, and then we will leave it like that. So we'll do that, and Resolve will take a few minutes, or a few seconds even, and then it will populate this bin with all of the rushes for this sequence. Now that looks pretty good. And we've now got timelines over here. So we have our rushes all in place, we have our offline reference, and we have an empty timelines folder. So we're going to go into the edit panel, making sure our timelines bin here is open. We're going to right click and choose timelines, import AAF/EDL/XML. And then to do that, we're going to go into our Scary Crows folder, and then we've got the Scary Crows Udemy timeline.fcp XML, and we're going to import that. So now, import timeline, grade export, yep. Timeline name, we're going to call this Scary Crows Work Timeline for now. We're going to uncheck automatically import source clips into media pool because we've already imported our material. We're going to automatically set project settings, we're going to use sizing information, and we'll set our timeline resolution to 1920 by 1080. This project was shot in a mix of resolutions between 2K and 3K basically for a final 1080 delivery, so we're going to leave it at 1080 and then we're going to hit OK. Now folders. Because we haven't automatically imported our source clips, we now get this folders dialog. We're going to uncheck it and check only rushes, and then we're going to hit OK. Now we have some errors here, as we should expect. We have a number of clips that failed to link because the timecode extents do not match any clip in the media pool. This means Resolve is looking for a clip with the right file name. It may have found a clip with the correct file name, but rather than it have the right timecode extents, for example like 3 minutes and 4 minutes, it's got something else, and that's because that clip is probably missing from that folder. We're going to have to hunt around and look for that missing clip in a second. But the first thing we're going to do is hit close, and then we're going to go through and we're going to check and see what we've got. So now that we have our timeline, we're going to right click and choose timelines, link offline reference clip and our Scary Crows Recycling Center offline, and then in our source viewer here we're going to click and choose the offline symbol. And remember, as long as these two frames are the same, our conform is correct. So now we're going to go through and we're going to check the conform we've got, and we expect to find some problems here. So correct, correct, okay, that is not correct. This is a wrong link, so something that should be here has not been here, and what I've done is I've made it link to my logo folder, my logo file, and that shows us now that this is the incorrect clip, so we're going to have to fix that one. We'll go through. There's a clip here that's just straight up failed to link. In all likelihood, that is actually missing from the folder we've imported from. Remember, we imported the whole contents of that folder. There's no way that we could have imported the whole folder and its contents and yet missed a file that was there. So what that tells us in all likelihood, the clip that we're looking for in this particular place is not actually in the original folder. And we're going to come back and deal with that in a second. Well, in a few minutes. We're just going to go through and check for errors. In fact, what I might actually do is I'm going to put a red marker down on the timeline wherever there's an error, and to do that there's this little symbol here. Click this drop down and choose a color, and then you just need to hit it there, or hit the M key, same as in Premiere Pro, to place a marker down on the timeline. And this is also incorrect, so we're going to hit M, place a red marker. In fact, we're going to place a marker on the timeline. Now most of this is correct, we just have some issues. We can see in the native clips we've had quite a significant lighting change or camera setting change here. We go from green to blue, so we've got a fair amount of work to do to match all this. We're going to go through and place red markers wherever there's a problem. There's another missing clip. We've got a good few bits of footage to work on here. I'm really happy to have been able to use this project to teach with. It's a really good one. And the client's very cooperative, which is always nice. And we're going to put some more red markers down there. Quite a few missing clips this time, but that's okay. We're here to learn how to deal with this. And there's another missing clip. So we have a fair few problems in this conform that we're going to have to sort out before we go any further. So we'll take care of the easy ones first, and that's these missing clips. So if we go back to Media, we've got our Trimmed Scary Crows folder. And then we've also got our Trash is Temp. Now I ignored this at first because it's not uncommon to have temp files floating around, but if I take a look in, lo and behold, we have some missing clips. So what we're then going to do, we're going to make a new bin, a bin within our Rushes bin, and we're going to call this Missing Clips. And we're just doing this so that we can keep a track of the new material we've added in case that should cause any issues. We'll go back one level, we'll right-click Trash is Temp, and we'll add folder and subfolders into the media pool. And that then brings all of these clips in. Now there's a chance that Resolve will have automatically repopulated the missing clips. And it tends to do that if you add new material in which hits a conform that's gone wrong, it will automatically try and solve it for you. And in a lot of cases now, I don't actually see any red clips. Now, we're going to have to do a final proof check of all of this later on, but for now I'm pretty confident that that's fixed it. So now, if we go to the little red checks, we can now see they're actually correct. So what we need to do now is go back and we need to fix all of the incorrect conforms. We need to go back and we need to fix all of the clips where my logo has come in instead of the actual footage. So this is the first one. In fact, if I'd had my wits about me, I'd have used a different marker. I'd have used yellow for the logo and red for the missing clips. That way I'd have an easier way of spotting where the error is, but live and learn. So now, these clips were in the first folder that we imported, but I deliberately made these edits link to my logo so that the wrong thing would appear in this place. We're now going to have to manually find the clip and put it in, and then make sure that it all syncs up with our offline reference file. Now this is time consuming and it's frustrating and it's boring, but it also happens, and that we know how to deal with these issues going forwards is really important, so you're just going to have to do this. So I've got my reference and my offline up here. I now need to go through the bins and I need to find the rush which matches this. Which I think is this one. If I just drag this out and place it here, I can see I've now got a match. So I've now found the correct rush. What I'm going to do is I'm going to right click over here. So with this clip active, I'm going to right click this here, and I'm going to choose Conform Lock with Media Pool Clip, and that will then forcibly insert this clip into the edit that was incorrect. Now, I've also zoomed my logo in a bit, and you can see this is too big, so what we need to do is hit the inspector up here if you haven't already done, and we're just going to reset the zoom in here by typing in 1. If you hit the reset arrow, it will reset the zoom value to the value that's brought over in the XML, which is not what we want here. We want it to be 1, not 135. So we're now going to go through and check, make sure everything is okay. Just going to play it through. And make sure everything is good. I'm going to keep going until we hit the next version of my logo, and then we're going to do the same manual fix. Here we go. This one might be a bit harder to figure out because there's a lot of angles which are very similar here, but if we take a look, I would say it's this one. We can see the hand in the bottom left and the hand in the bottom left there. We can then just check that. Lo and behold, that is correct. So then we're just going to get that. Right click, Conform Lock with Media Pool Clip. And there we go. And then we're going to make sure that our zoom is 1. And we've now fixed that. Got a few more red checks here. That's correct. That's fine. Yeah, we've got another logo here. So now we're just going to have to go through and find the match. And that's a mid of him standing against the garbage pile. Okay, there are a few here, but I think this is the match because the... let's just see what happens. Yeah, he runs forwards, and if we scroll over here, we see he runs forwards as well. So this is the correct one. What we'll then do is we'll just right-click Conform Lock, and then we'll just play that through. Perfect. Yep, fine. Got some particularly difficult lighting here, but we'll take care of that. We've got a fully finished conform here. That took a little bit longer than last time. This was a pretty basic conform. What we're going to do is we're going to save now. We'll call this Scary Crows Real World Project, or Practice Grade, better. Scary Crows Practice Grade. And then we'll save that. We want to make sure that we've saved now that we've done all of this work. So conforming a feature film is, well, conforming an indie feature film is much the same way, just on a larger scale. You can typically expect to put like between a full day and a half day aside to make and proof check the conform, and that depends on how many errors there are in the conform that you're doing. If you get like a full 2-hour-long feature and it's just riddled with conform errors, then that's going to be a full working day. Or you can get a really basic, really simple, I say basic, you can get a really clean conform, and it might take you 2 or 3 hours because you have to watch the whole thing through with your offline reference to make sure that it's fine. But once you've got that sorted, you can then begin working. So this is a good start. In the next few lectures, we're going to have a quick chat about RED and what's the difference between RAW and footage, because this is the first time in this course, anyway, that we've worked with a RAW format. So we're going to have a quick talk about red, a quick talk about raw, then we're going to go into look development and how this feature film is different from the other two projects as well, because we're going to work in a different way here. We're going to have a different attitude towards the grade we're making, and it's very important that we get that down. So click on through to the next lecture once you're ready. Okay, we know how to set the contrast of our image, but that opens up so many questions. What should be where? How bright should a face be? What's the ideal for a highlight and why? We've covered the very basic rule of thumb for contrast, setting our core blacks and our brightest whites. But we also recognise that those two rules don't apply all of the time. There are plenty of situations where bringing the waveform up to the top of the scope would not be appropriate, and there are also times when setting a typical core black is not the way to go. So then, how do we know where our contrast should be? There are a few variables that can complicate this, so we're going to break it down into different conventions and why and where they might be appropriate. Now, we've already covered the first, and I've graded this image according to that convention, where we set our core blacks at 0, and we set our highlights by I, and then play with the mids until we're happy. Now, this is fine if you're just starting out, and it's also great for web videos as well, because pretty much what you see on your monitor is what you can expect most web viewers to see on theirs. And for the most part, this course is delivered online, so you all have a monitor or a laptop screen to work on. And I've used these basic conventions on most of these practical projects because I can't expect you to go and check this on broadcast or in an actual cinema. But when we think about cinema and broadcast, there are some different standards to keep in mind. Now, we go into much more detail on the differences between different viewing scenarios later, but for now you just need to know that monitors, televisions and cinema projectors display images differently. These differences are why we might choose to use a different contrast convention, because one of the key differences between all of these screens is something called gamma, which has a direct effect on the perceived contrast of our image. Now again, we cover this properly later. For now, just know that the three main viewing scenarios, which is web, TV and cinema, all behave differently. Now, with that out of the way, we can move on to the fun stuff. Let's take a look at a different way of setting our contrast and why we may choose to use these conventions as opposed to the basic core black stroke brightest white approach we covered earlier. Now, before we go any further, I'm going to change from the Luma waveform to the parade, because there's also a trick to read the parade that helps us get a pretty accurate read on the brightness and contrast of our image. The majority of the brightness in any RGB image is derived from the green channel, so that means that the green wave, down here in the lower right, gives us a reasonably accurate idea of our contrast without needing to refer back to the Luma waveform constantly. Now, it's not 100% accurate, as it's not a full reading of the brightness, but it is actually good enough for us to base a lot of our grading decisions on. So, let's take a look at a different set of contrast conventions. Like we did before, we're going to start with the shadows, and I'm just going to reset this one, and we're going to start from scratch. Now, on web videos, we do have a reasonably good visible range at the very low end of the waveform. This changes in broadcast and cinema though, especially in cinema. Contrary to the typical core blacks at 0 approach, there is another convention. We're going to bring our blacks down to roughly 90 on the scope, maybe about 65 or so, and I'm going to make this judgment looking at the green waveform down here. The green waveform is a reasonably good stand-in for my Luma waveform when I'm using the parade scopes. Now, we're bringing it down to kind of 60 to 90 and not 0, because the perception of detail is diminished when we go below 128 on the scope. Now, I say diminished, not eliminated. I find that leaving my shadows at 128, like this, it just looks too milky and washed out. It's a very kind of Instagram, washed out, blooming indie hipster look that I don't really like very much. So I'm going to bring my shadows down to around 60, between 80 and 60 around here, and that's okay for me. Now, on a PC or a Mac monitor, that does look a little elevated, and this look plays better in broadcast and cinema. Unless the client is going for a washed-out indie type of look, I tend not to use this convention for web video. But in corporate ads for broadcast, it can give a nice, refined feel. It can give that nice kind of, not washed out, it gives a kind of relaxed feeling. It can be very good for things which are meant to be quite upbeat and very kind of pleasant, which is where most ads aim for. So this is where we can put our shadows, and I like there to be a little bit of bite in my shadows, so I'm just going to bring this down here. Cool. So next, we're going to take a look at the highlights, and there are a few things to keep in mind here. We used to just set our highlights by eye, but there's actually more to it if we understand the type of highlight that we're using. And there are two kinds of white in film. The first is reflected white, and the second is emitted white. Reflected white would be a white object, a shirt, a white wall, or any bright material. Any white object which reflects light back to our eye. Right? That's a reflected white. An emitted white would be a practical light, an on-set light bulb, the sun, the moon, the stars, specular highlights, which are those very shiny spots you get on glossy surfaces. There's also an argument for treating the highlights in clouds as emitted whites as well. Now, the upper limit for a reflected white is broadly considered to be 896 on the scope for the green waveform. Beyond this point, just like the shadows, the perception of detail is diminished, and things also begin to glow, making it look as if light is being emitted from that surface. So white cloth, walls, and anything that's reflecting white light should max out at 896 on the green channel. Now you can see in this particular shot here, we've got the actress's shirt, which is a reflected white. It's a white shirt, it's in the light. This is the brightest thing in our image. So I can stretch our highlights up until, there we go, the green part of that reflected white just hits 896, and that's much better than me dragging it all the way up to the top where it goes, you get that kind of bright glowy effect and we start to lose detail. So I'm going to bring my reflected white highlight here up to 896. Now emitted light is different. Emitted light can go all the way to 1023, just like a standard maximum highlight. This convention helps us a great deal when we're trying to get a feel for where our highlights should be. There's a simple question. Is the bright spot a reflective object, or is it actually emitting light? Once we can answer that, we know where to place it on the scope, and that's just a simple task, as we've seen. Now, because I've stretched out my highlights, I need to bring my shadows back down. So I need to there we go. Bring that down until about 80-ish there, and then just tweak the highlights again. Cool. So this image is starting to look pretty good. I'm going to do the standard thing now and add a bit of contrast, saturation I mean. Now I need to be careful with kind of glowing areas of the skin, and the shadows aren't as low as they could be, so they can take on a kind of glowing aspect if I'm not careful. And I'm going to bring my mids down a little bit as well. So there's also one more thing that we can keep in mind, and it's specifically about skin tones, and that makes it very important. Remember, human skin tones are typically the most important colours in any film image, right? Because that's where the actors are, that's where the performance is, and by extension, that's where the majority of the story is in our images. This is a good one to keep in mind, as the contrast on a human face is extremely important. The big thing to avoid when grading skin is to give it an accidental glowing appearance. It looks odd and artificial, and it immediately reminds us that we're watching a film because it's clearly a technical error. We can avoid this by keeping an eye on, and you've guessed it, the green waveform. Now, when dealing with skin, the green waveform should stay below 768 on the scope to avoid problematic skin highlights. Anything above this can give us a very artificial looking kind of glowing highlight, which is best left avoided. So you can see the highlight in the green here. The red can go a bit higher because skin is red, but the green should stay below 768. That's kind of like the maximum for skin highlights. Now again, this is more of a broadcast stroke cinema thing. If it looks good on a web video doing that, don't be afraid of breaking this convention. It's a convention, it's not a law. The color grading police aren't going to kick your door in and arrest you for changing your mind on this, so don't worry. So what I can then do, if I bring it up, what we can see is those highlights on the skin appear to kind of glow and look too kind of bright and artificial. So I just need to bring that down, and maybe I'm going to add a bit of orange in. There we go. Maybe a little bit side in my shadows, clean that out a bit. And the overall contrast of that face is looking pretty good. I've got the reflective shirt at 896. I've got my skin highlights at 768. I'm pretty happy with that. So then I'd go on, I'd do all my secondary stuff. I can do all the other stuff we've covered so far. Now, one thing to keep an eye on, if the color balance of your image is a little bit off and we get a lot of red, then you can still get that glowing feeling if the red is super high up here. If the red's kind of above or on or above 896, then you're going to get weird glowing skin highlights. So you just want to keep an eye on that. If you have a lot of red in your image, what you might want to do is just push a little bit of cyan into your highlights to bring that back down again. Then you can compensate by adding a bit of warmth in the mids. And then you can get your skin highlights in a nice place. I'm going to bring my mids down. This is quite a dark image. Remember, it's about scarecrows that go around murdering people. So, there we go. There we go, and that's this image with the primary grades carried out to a different set of contrast conventions. These are good ones to keep in mind, because if you go ahead and you do the very popping, the very high contrast basic look, a lot of corporate clients aren't super keen on that, and they like this kind of contrast instead. A number of very kind of hipster indie style clients, I guess is the only way I can describe them, like it to be even more washed out. They really like the kind of almost log look. So you just have to keep that in mind and talk to your client, get a brief, get references, see the kind of things that they like. What you don't want to do is go, okay, yeah, I know how this should be done. Here's the basic contrast grade. And they go, oh no, wait, this is far too contrasty. So always talk to your client, always get that brief, and so you know what you're aiming for. Now, with these conventions in mind, we can better prepare our projects for broadcast and cinema, although keep in mind that you still need a calibrated monitor to do that properly. We can also use these conventions if we need a film with a different feel from the standard basic approach to contrast that we covered earlier. The only thing here that I would strongly recommend you stick to would be the conventions concerning skin tones. That particular convention tends to be quite useful under most circumstances. Unless you have very extreme or stylized writing, that tends to be a pretty good one. Right, so we've now got a more thorough understanding of contrast and where it should be. Once you're ready, click on through to the next lecture. Right, we're finally nearing the big leagues. This real-world project was shot in a Red Scarlet, and this is our first exercise using a RAW format of any kind. So before we jump on in, we have to cover some of the basics of what a RAW file is and the key differences between footage and RAW. Now, we'll go into full tech about this later. For now, we're going to cover a working understanding of the subject. This module is a real-world project. After all, it's not a tech-dedicated module. Now, the basic difference between footage and RAW files is that footage has already been encoded a certain way. Footage will only show you one version of that recorded image. That image may appear different depending on the viewing environment in which you view it, but that's it. A footage file has an ideal viewing scenario in mind, like broadcast or a computer monitor. RAW is fundamentally different from this. RAW files consist of the information that struck the camera's sensor. Now, this might sound just like footage on the surface, but it is not. With footage, the camera takes that info that results from light striking the sensor and then encodes that information using what we call a transfer function. We'll go into what that really means in a later module. For now, we only need to understand that a transfer function takes a set of original values and changes them to a different set of values. This process cannot be undone in standard footage files, and we only have what the camera originally encoded. I have a clip from the very first practical project here, and these are my decode settings in the bottom left. You'll notice they're all greyed out. I cannot decode this clip in a different way. It's always going to look like this to begin with. Now, I can change the information here through a grade, but a decode and a grade are not the same thing. That is really important. This is our only starting point with this file. I can't change this. I can't manipulate this. We're always going to start with this image, right? Now, we're going to go back to RAW. RAW files consist of raw information that rises from light striking the camera's sensor, and I've got 3 RAW files down here. Some RAW files have not yet been encoded with an irreversible transfer function. What this means is that RAW files, like R3D, can be decoded several different ways to result in a number of different versions of the same recorded image. Now, I've got 3 RAW files down here, 3 red clips. They're all the exact same take, but they have a different decode, and look at the difference between them. And then compare that to our footage at the end. Now, this isn't a grade. The difference between this clip and this clip and this clip, this is not a grade, this is just decode. It's these settings down here. Now, we always have the raw data, hence the name RAW, and we can choose to decode that in a way that best suits our workflow for our final viewing environment. In the case of R3D files, we can choose from a plethora of different options. In fact, the old R3D pipeline could get a little confusing. There were hundreds of combinations to choose from. The newer RED cameras now use something called the IPP2 pipeline, which is much more streamlined and easier to use. Our project uses R3D files from an older Red Scarlet camera, so we're stuck with the pre-IPP2 pipeline for this project. Now that we've covered the meaning of RAW, we're going to go over a proper intro to working with R3D files in the next lecture, so click on through once you're ready. Now, we're actually going to cover working with R3D files and the additional steps and concerns that they raise. There are a few things to break down here, and we're going to start with the decode. Note that this is a working intro to the R3D format. We don't deep dive into the tech here, as our aim is to deliver the current project. There will be more advanced tech later in this course. So, RED cameras encode raw data into R3D files. That data can then be decoded through a number of different settings to produce a starting point for our grade. We can find these settings in a few places. Firstly, we can click the gear in the bottom right. We can then navigate to the Camera Raw tab. By default, this starts with the decode settings for ARRI RAW. We need to use this drop-down menu to select RED. We now have a number of settings to choose from. Please note that this is a decode for an older RED camera. It is not the ideal decode for a recent build using IPP2. We'll start with bit depth and we'll go over decode quality later on. Bit depth selects the bit depth for the footage we're working with, how many colours we have to work with. The higher the bit depth, the more accurate our secondary qualifications will be, in layman's terms. We covered bit depth in a previous lecture, so generally speaking higher is better, though on machines with a lesser spec it might start to slow things down a little bit. The timecode must be set before we bring any R3D media into the media pool. In most cases, leaving this on camera is fine. The second option is absolute. This uses a time of day timecode using the 24-hour clock. The timecode that rises from this depends on the time of day that footage was actually shot. And the edge option makes every single clip start at 1 hour, then count forwards from that point. In most cases, absolute is of more use to us. And finally, we have decode using. This gives us a few different ways to decode our footage. It has the RED default and RED camera metadata settings. RED default may not be applicable depending on the camera settings used during the shoot. Camera metadata uses the camera settings on the time of the shoot to decode the footage. Now this sounds like it might be useful, but I've often found that it doesn't really help. I always find that manually setting up a proper log decode yields the best results. We're going to choose decode using project. This allows us to set our decode settings manually, and we're going to go through the relevant options one by one. So first, color science. We're going to set this to version 2, which is appropriate for our older RED Scarlett camera. Original is the best fit for much older cameras, like the first few runs of the RED 1, and IPP2 is the best choice for newer cameras which are using the IPP2 pipeline. So we're going to choose version 2 for this project. Color space. Now there's no hard and fast rule here. You can eventually manhandle any choice in this list into the right place for your project. That being said, we should always try and give ourselves the best starting points. I'm not going to summarize every possible choice here. For now we're going to choose Red Color 3. This is going to help us out a bit with our skin tones and give us a great starting point with our Red Scarlett shot footage. The next setting is Gamma Curve. This has a much larger visible impact on our decode. When choosing our gamma curve, we typically make that choice based on a few parameters. First is the amount of time we're going to spend on our grade. Are we going to go full on and grade in fine detail? In that case, something like red log or red log film is a good choice. These choices mimic what is known as the Cineon curve. More on that in a later module. But basically they provide us with the widest latitude whilst grading. Other choices like Red Gamma are more geared towards providing a decent image that only needs a few tweaks. Now we're going to go in and grade in detail here, so we're going to choose Red Log for our gamma curve. So all the other options for now don't matter. The last setting we're going to cover is decode quality. RED files are recorded through a technique known as a Bayer pattern filter. This kind of misses some pixels out when recording. The machine we're working on then uses an algorithm to fill that missing data back in and gives us the best quality image. This is referred to as debayering. When looking through these options, we see that we can choose our resolution and a good or a premium decode. Good does not debayer our footage, it does not fill in the missing pixels. The visible result of this is that we see a kind of blocky noise on our image. This is the fastest choice. Using good quality decodes will make it easier to work on the actual grade. We can then set our machine to render out with the premium quality debayer at the end of the project. Now you need to experiment with these settings and see the impact that it has on the performance of your workstation. If you're using a laptop or a MacBook, start with half res good and move down to quarter res good if that's too slow. If you have a desktop workstation with a decent GPU, let's say GTX 1070 or better, then try half res premium. You can always take it down a notch if you lose performance. Don't forget about the render cache when working on this project. 1/8 and 1/16 res make important details unintelligible, so caching is preferable to using those settings. Now, this has been a good, if somewhat basic overview of R3D and Resolve. We're now ready to get to work. Click on through to the next lecture when you're ready.